All right, welcome back everybody. We're going to finish up by doing the graphing parametric. Now, one of the things that you're kind of already familiar with is that whenever you see x and y in sign, that's generally going to give us a circle or an ellipse depending on the types of values that are happening here. So let's just get some points here. Now again, I'm not going to get all of them, but I know if I get roughly these three, it'll tell me exactly the direction I want to go. And so if I plug in 0, remember sine of 0 is 0, cosine of 0 is 1, sine of pi over 2 is 1, cosine of 0 is, cosine of pi over 2 is 0, and then finally sine of pi is 0 and cosine of pi is negative 1. So just by looking at these coordinates, 0, negative 1, oof, that's a real bad line. So 0, negative 1, negative 1, 0, 0, 1. We can kind of see the formation of a circle. And so we can also see the orientation, the direction that this is going. So we want arrows going this way. So it's a circle with a radius 1. Now for this one, we want to eliminate the parametric first. So, or the parameter. Now remember, these are kind of general equations. So by isolating cosine, I get x minus 1 divided by 3. And by isolating sine, I get y plus 1 over 2. Now I'm going to square both sides, and I'm going to do this kind of selectively. I'm just going to square x minus 1 like that. I'm going to square y plus 1 like this. And I'm going to add the components together. So once I've added them together, I know this has to be equal to 1. And we can see that it is an ellipse with a center at 1, negative 1, with a x radius of 3, a y radius of 2. So 1, negative 1, go out 3 in each direction. Now this one doesn't ask to graph the foci, so we're not going to worry about the foci. Now the only thing is that we want to determine direction of the parameter, okay? Oh, and we only want this between pi, which means we're going to take off some of these coordinates. So if I just get the 3 coordinates that make most sense here, 0, pi over 2, and pi, showing start, middle, stop. Plugging in 0, I get the coordinate 4, negative 1. Pi over 2 gets me 1, 1. And pi gets me negative 2, negative 1. So if I just think about these 3 coordinate points, 4, negative 1 is here. They take me up to 1, 1, which take me down to here. So what I'm going to do is I'm going to just erase the component of my ellipse that's not being used in the parameter. Now, you didn't have to do all that. I just kind of got carried away once I got the information. What I'd really recommend is you get the 3 coordinate points you want and then rewrite your equation. That way you know the shape. And again, sketching by eliminating the parameter. So again, this is a entire parameter, so it doesn't matter what order I do this in. What might be helpful is looking at the eliminated parameter first by putting it in rectangular form and then going from there. Now the key to this is pick which one you think is going to be easier. You can replace either one. I'm going to isolate t here because I don't have to worry about square rooting stuff, which generally gets rid of plussing and minusing. So what I'm going to do is I'm going to take this, I'm going to substitute into here, so I get x equals 3 times y minus 1 squared. And right from there, I can tell that this is going to be a parabola with a center at 0, 1. So 0, 1. up here. And since it is a y squared equation and they both have the same sign, that means it's going to open to the right. I'm not really focused on the coordinate points all that much. But what I would do is go back to the parameter to figure out direction. And we can pick 3 points again. So I might pick -1, 0, and 1. So when I plug in those coordinates, I get at -1, x is 3, and t is 0. So 3, 0. No, I might need to go back and revise my graph a little bit here. It's a little bit off now. Let's pick 0. Okay, let's get the points first. So I get 0, 1. We have that one. And if I plug in 1, I get 3, 2. So let me plot these 3, 3, 0, and 3, 2. Now again, if I look at the timeline of events, I go from 3, 0, so here, to there, to 3, positive 2. And so we can see the order that the parabola arc needs to go. It needs to go from bottom to top. Again, oops, that's the wrong direction. Common mistake, we're so used to putting them this way that arrow is actually confusing because now it's saying it's going both directions. So I know it's a little bit weird, but we're not inherently putting arrows showing it's going on forever. We're kind of assuming that. And then this last part here, really nice and easy. Write 2 different parametric equations for the rectangular coordinates. Again, the free one is always the best one, t equals x, which means you just substitute t into the equation for y. So you get 4t cubed plus 5 equals y. That's the first one. And then you can choose whatever else you want. I just tend to pick 2t. This kind of speeds up the graph. I just think 2t is really easy. You could even do -t if you wanted to. That would change the orientation or the rotation of the graph. So if I cube it, 2 cubed is 8, 4 times 8 is 32t cubed plus 5. So that's another one. And here, if I make x equals t again, always choose that one unless you're told that you cannot for some reason. And then maybe just for the effect, maybe I say t plus 3. And so I would do 4 times t plus 3 for x. And distribute the 4, so we get 4t plus 12 minus 1. 4t plus 11. So those would be ways to write your parametric equations. Okay, so I hope this review was helpful. Feel free to go back and look at any of the questions again, and let me know if you have any additional questions. Thanks. See you next time.